Okay, and off we go. All right, you know what? I'll do the same thing I did last time. We'll do these little funny Kahoot things. So sorry. These ones are a little trickier to do here because without a piece of paper it's hard to trace them out, but that's fine. But once we do that, then we'll carry on with this thing called for loops. So for loop, pretty simple. Change the word while to for, you're done. Unfortunately, it's not quite like that, but these are actually really, really convenient. Luckily, they're not difficult, they're just really convenient. Okay, I have to take that back. If you're good at writing while loops, you'll find this to be extremely convenient. If you're not good at writing while loops, this will be just as tough as while loops. Okay, so I guess that's going to be kind of fair. All right, so let me get a little Kahoot going here. So this is about while loops. Okay, this is the right one. I don't want to cover something we haven't done. Okay, so we come over to here and continue with no island and go ahead and start. Again, I'm kind of stuck here at 40 people, so I mean, if you don't get attached, okay, well, it can happen. You can at least watch. Okay, here. There we go. Otherwise, the weird silence keeps kind of strange. Okay, how do we do? 22. Okay, we can get twice as many people in here yet. Or everybody else just wants to sleep. Okay. Okay, 23. One more. Okay, and then one goes away. Okay. Yeah. For loops. Yeah. Next one. For loops should be for number 5. So I think that's a number on it. We'll find out when we flip back over to it. For loops. Okay. 29. Okay, so it looks like we got ourselves about 30. Okay. So if you didn't get a chance to join this time, there'll always be next time. At the end, I'll add up all the bonuses and give some extra marks to people who joined in. Okay, off we go. No, actually, I won't do that. But anyways, here we go. So while loops. Yeah, it's the stuff, obviously, it's not the stuff we're about to do. It's stuff we did just yesterday, or sorry, day before yesterday. Most of these are what's the output of this program. So here you go. And I apologize, piece of paper, yes, it would make it easier. But if you know what to look for, it shouldn't be too bad. The significance of the number 65, it is an uppercase A in terms of the ASCII values. 34, just some random numbers. It doesn't have anything to do with the characters, but just distractions. Okay, 23 answers. Well, there's a lot more than 23 people who joined. Okay, so we're almost there. Okay, so what do you think we've got? Okay, big spike on the correct one. Good. A few people, well, sort of a big bulk of people went after the number 5 rather than 15. Okay, yeah. As I said, this can be a little tricky because Oh, sorry, 15 people. I got the wrong number. It's a 4, not a 5. All right, so remember how this ends up working is this is a counted loop. It goes through exactly 5 times, okay, because we got this thing right here. So it's really just a matter of being careful about how many times count goes up. But of course, the counter starts at 1. Okay, so even though it's called count, that's not the loop counter. The loop counter is the b is equal to 1. Anytime that I ever write a counted loop, I can guarantee you I will always initialize it just before the check on the loop, and I will increment just at the end. Whoops. Okay, I didn't this time. Okay. Okay, we'll see those at the end. Okay, so user types 5, then 50, then -1. So 4 inputs. What's the output? So 5 enter, 50 enter, -1 enter. Okay, and what did we get? Uh-oh. Not doing very well on these. You heard that the course has a high failure rate, right? Okay, so at least you're playing along with it. It shouldn't be like this. Okay, it seems like a lot of people went after the number 10, and only a few people got the correct answer of 9. Okay, we better look at it. Remember, the user enters in a 5, a 50, and a -1. We're eventually outputting A. A starts off at 0, no problem. Person puts in a 5. On line number 5, is 5 less than 10? Yes, it is. So A goes up by 5, so A becomes 5. All right, it's not a -1, so we don't break, and we continue. We go and ask again. We ask again for a second value. The second value gets put in as 5. 5 is less than 10, so I end up doubling it to total of 10. Check and see if x is equal to -1. It isn't, so you don't break. You go back up to the top. True is true. You ask for the next number, which is -1. All right, so we asked for the value of -1. Is -1 less than 10? And if you take 10 and you add -1 to it, you get
9.
Yeah, 9. All right, and then we hit this if statement right here that says, is x equal to -1? Yes, it is, so then I break out. Okay, so remember, it's one after another. It isn't like, oh, when it's -1, it'll break. No, it's very, very sequential.
What about 50, like 5%?
Well, okay, sorry about the 50. Okay, sorry. We can inject, it won't make any difference. 50 comes in, is 50 less than 10? No, so that skipped. Is 50 equal to -1? So that skipped. So sorry, I skipped it. I shouldn't have. Okay, this one, but the catch wasn't the 50, it was the one extra time through. All right, so, no, but the test questions will be easier, right? They'll be like this. So that's why we do these things. All right, here we go. No, not yet. We'll see that next time. All right, number 3. Oh, the user enters 5, 50. I'll try to remember it this time. And a -1. Oh, it's the same question, so it must be 9. Well, x does not equal to -1. That means not equal to. It would have been covered in infs1201. Find out something's equal to its two equal signs, not equal to its exclamation mark equal. I'll add that to the notes to cover the in the operators part in the first part next time. Okay, how do we do? Okay, good. More people got it correct, so that's better than the previous time. So you had an idea about what's going on this time. Okay, almost. It was a little bit different. The difference between this one and the previous one is I have this extra input just before. So I asked, what's the first value? So the first value gets put in as a 5, and I asked the question, is 5 not equal to -1? And that's true. 5 is not equal to -1. So I come in and I ask for the value. The user types 5 the second time. Okay, and then I continue doing the same thing as less than 10, so I add it. So now A happens to be 5. I come back through, and 5 is not equal to -1, so I ask again. Person types in 50. That's ignored. Back up to the top. The person types in a -1 right here. I come down to here. It is less than, so the 5 then becomes a 4. And then I check right here if x is equal to -1, break. Okay, so I didn't actually need this one this time, but I left it in because it kind of matched the previous. Okay, so better. All right, one more question, and then we'll move on to for loops. Okay, so how many times does the word hello appear in the output of this program? So lots of printings of hello. A lot of people went after the wrong number again. A lot of people tried to guess for 1, but the correct answer is 3. Let's see if we can work this out. All right, x is set to 3. Okay, of course, we're counting how many times does hello appear. All right, so while true is definitely true. I print the word hello on line number 3. Excellent. I then ask the question, is x bigger than 10? And the answer is no. Right now it's 3. Okay, so I carry on and I say x is equal to x plus 10. So that means x becomes 13. I don't have 13 fingers. All right, but what immediately happens is the print happens again. So now we've printed twice. We go back up to the top of the loop and we ask, is true true? Of course it is. So we do the stuff inside and you say print hello. There's a third one. But then I'm going to ask the question, x is currently 13. Is 13 bigger than 10? Yeah, so therefore line number 5 triggers your break and you're done. So 3 times. Okay, again, these are not things like what will happen in the future. And so, I mean, maybe that's the reason why a lot of people went for the 1. No, you have to follow the logic, okay? All right, so, I mean, these are the types of questions that will show up on midterms and then the final for tracing. I try to avoid having too many iterations through the loops. Because, I mean, if I asked you to iterate 10 times, this would be really annoying. 1 time through the loop is certainly okay. 2 is okay. 3 is kind of like the absolute max I would ever do. So if you find yourself on a test iterating more than 3 times, you probably have a problem. Okay, you're probably doing the wrong thing. There's no guarantee. It might be correct, but I try to avoid that because it's just wasting a lot of time. Usually having 2 or 3 times through where I can check to make sure students understand what a break is and what a continue is and how it works, that's it. And then, oh yeah.
Will we be able to do this at home? Like, can we open this Kahoot quiz at home?
No, but you can open the video and watch it.
Oh, okay.
Okay, so it is here for this. Sorry, I don't know how to open these things up for like general purpose when people want to do it. Okay, but the videos are here. Yeah. Okay, we're counting how many times word hello shows up. Okay, I don't have an extra variable. I suppose okay, give me a second. We can have a variable over here. X is 3. Here we go. Here is my. No, sorry, I can't put a variable up. Okay, the variable x is initialized to the value 3. Loop begins. It's an infinite loop. It keeps going either to infinity or until it breaks. All right, line number 3 happens the very first time. That's 1 hello. We then ask the question, is x bigger than 10? No, it's currently 3. So the break is skipped. X goes up by 10, so it becomes 13. All right, line number 7 happens. There's 2. That's 2 hellos. And then, of course, after line number 7 comes line number 2. Line number 2 happens, true is still true, so I go in and I do line number 3, that's another hello. And then when I hit line number 4 the next time, I ask, is x bigger than 10? Yes, it is, because now it's 13. At that point, I then break and the program is finished. Well, the loop is finished and the program is finished as well. That's why it's 3. Okay, so the reason why we include these types of questions, by the way, it isn't just, I mean, oh, yeah, it's fun to watch people sweat. No, it's not about that. It has more to do with, you can ask about how do these constructs work. Okay, so congratulations to our winner. You win absolutely nothing, but thank you for playing. You can participate again next time, and there will be, okay, how do we leave this? Okay, here we go. All right, so these types of things are really, really useful for checking to find out, do people understand the concepts that are going on in terms of structure, in terms of flow? Because if you don't understand the flow, you'll never understand what you've done wrong. Okay, well, what if you just never are wrong? Okay, well, here's the deal with programming. You will always be wrong at some point. The only difference between somebody who can't actually write a program versus somebody who can is when the person who can write the program realizes that they're wrong and why they're wrong, and then they can fix it. Okay, that really is the difference. All right, so you will always be wrong. Trust me, the number of mistakes I've made already programming today, it's a small number, sorry, it's a big number. It continues to grow. All right, so here we go, for loops. Okay, so one quick little drop into the slides, and then we will pop over to other things. All right, sections from the textbooks. Yes, I know break and continue was probably in the previous, but it comes back again here this time. All right, so one of these reveals. So this is our introduction. Okay, I was looking around trying to find at least some kind of an inspiration to say, okay, what's a big system that people would know that's written in Python? Because Python isn't just something that you do in first-year programming. It is actually used. So I don't know if you use Instagram or not, but certainly there's certainly a lot of people who do use it. And for the most part, the back end is written in Python. That's what I've been able to acquire online. So it is actually used for real purposes. Okay, now, how many loops? Oh, and the estimate that I found online said it was about 100,000 lines of Python code. So any idea about how many loops you think there would be? Oh, by the way, there's lots of functions and modules and so on. It isn't just like 100,000 lines of code. But how many loops might you have? 10 loops? I did some hunting around, and kind of based on my estimate, I thought maybe around 10,000. Okay. Is that accurate? I have no idea. We don't have access to the code base. But I thought, okay, most loop bodies, if you look at it, loops usually have how many lines of code in them? Right. Well, usually you wouldn't have more than about 10 to 20 lines of code, but you might be calling functions that will have these things. And kind of the estimate that, again, I was sort of able to achieve by kind of poking around, there was kind of a suggestion that maybe 10,000 loops. Okay, even if it's not true, yeah, there could be this many. Now, out of this, remember, I've shown you that there were 2 types of loops. There's basically loops that go until the stopping condition occurs, and there's loops that happen a certain amount of times. We call the loops that happen a certain amount of times counted loops the other day, and loops that go until some condition arises is called a sentinel loop. Okay, it's not always that the user enters something. It might be that some other condition happens to be true. Okay, so out of this, the next question was, okay, well, given the proportion, how many of these things would likely be counted loops? And again, there's kind of no guarantee of this, but sort of poking around, it seemed to be suggesting, from what I found, that there's probably like between 6,000 and 8,000 counted loops. Okay, and the rest of them, sentinel loops. Okay, and again, that doesn't mean the user interacting until the user types -1. It can be used for a lot of other things. Like, for example, sometimes what I will do is you might be looking through a list of a bunch of things, and when you find what you're looking for, you stop. That's kind of a Sentinel-based loop, because you don't know how many iterations you're going to go through until you're actually executing. So based on this, most of the loops are counted loops. Okay? And really they are. Most of the loops that you end up writing and programming tend to be counted loops. So people created something called a for loop, and really all that it is, it's a really convenient way of implementing a counted loop. Because with a counted loop, you got to remember, initialize the variable before, put the condition inside the while, that's pretty easy, and then you have to remember to increment the counter at the end. You know how many times people forget to increment the counter at the end? And if you do, you end up with an infinite loop. The amount of times that this happens is really quite phenomenal. So a for loop, the idea behind it was basically to be a shortcut that we could use that might do some of this stuff automatically. Okay, or at least in a slightly more convenient form. All right, the next few things are code, so I'd rather actually type the code so we can talk about it. All right, so here's what we're going to do is let's write up a simple counted loop. Old style that we just did a few minutes ago, so here we go. I'll leave a comment to say what I'm going to do. Print the word hello 10 times. Okay, using a loop, of course. I don't mean copying and pasting. All right, so how would we do this? Well, we would have some kind of a counter equal to 0, and you'd say, well, the counter is less than 10, and you would say print hello. Of course, if I run this right now, it's an infinite loop because I forgot to increment. Trust me, it happens all the time. If I've written any today, I don't think I've written any infinite loops today, because most of the loops I write are counted loops, and I use the equivalent of 4. That's how I managed to avoid them. All right, and of course you go up by 1, and then you're followed by the rest of the program, whatever problem you're solving. Okay, not a big surprise. You run that, and here you go. Did it happen 10 times? I hope so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so yeah, we got 10 times. All right, okay, there you go. That's using the existing constructs that we understand. Okay, it's time for a new piece of syntax. Okay, the format looks a little weird, but here we go. For. Okay. I have a variable called counter, same as before, and what I'm going to do is the words are a little bit different. The first word up is the word in. Now, we've seen the word in already. We saw it when you're looking inside a string to see if its character is there. It means something different this time. Okay, and what you do is you can list off something called a range. Okay, and we'll talk about the range here in a few seconds. And what I'm going to do is I'm going to print out my message, hello. All right, let's clear the screen. Okay, and we'll run it, and we'll just make sure that it works, and we'll talk about what's going on. So here we go. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, so 10 times. Okay, is it less typing than the other one? Okay, a little bit, but you'll notice something that is missing. The counter is equal to counter plus 1. Yeah, that is happening automatically. Well, not exactly because of the way how it's being implemented, but there is something new. It's called range. All right, and of course, if you stick a number, well, it's pretty easy to see what happens. Yeah, it prints the value, it repeats the operation 10 times, whatever number's in there. If you wanted to change this to a 4, it's not a big surprise. It prints exactly 4 times. If you ask for 0, it doesn't print anything, but it's not a problem. Okay, the rest of the program would continue. So let me just stick a done down here so I can say that yes, it doesn't cause any troubles. And if you ask to go -1 times, no, it just completely ignores you because it's already there.
Oh.
Yeah, print -1 times. Yeah, already done. Just like it was done with 0. All right, so yeah, you can stick any number in here that you want. Let's expose something because, wait a minute, what is counter? Okay, well, we better find out what counter is. First of all, let me put this back to something normal. Okay, so the counter, it says 5, so we know hello is going to be printed 5 times. Absolutely guaranteed. Okay, let's look at a couple of things. Let's take a look at the type. Okay, let's start by taking a look at the type. It's going to print the type over and over and over again. When you print it, look what type counter is. Yeah, it's an integer. Okay, that's kind of interesting. I suppose what I should do is I should also print the value of the counter, because that might be really, really useful to us. And these are the values of the counter. The very first time through, it came back with the counter 0. And then it came back with 1. Then it came back with 2. Then it came back with 3. Then it came back with 4. If you remember, when I wrote my while loop a few minutes ago, where did I start counter? Because I always start the counters the same way. Start at 0, because I said most people who write loops usually don't start counting from 1, because the computer really likes the number 0 inside. So there you go. So this is a way how we can deal with writing up a loop. You don't need to print the counter. If you want to see it, it's quite helpful, but it's a very convenient way of writing a counter loop. You don't have to remember to initialize. You don't have to remember to increment. It just happens. Okay, so that's pretty convenient. Okay, is it absolutely necessary? And the answer is, of course not. The same thing, of course, we can now start to replace this with real programs. So here we go, 1, 2, 3, and 1, 2, 3. I don't know why I've got so few slides today. We might be finished early. Don't say anything. Here we go. So let's come back with a problem that we've seen this before. Write a program. Yeah, this is me trying to take time. Write a program that asks the user to enter. Okay, I have to take time. Enter 10. Okay, I won't be this slow. 10 item amounts and compute the total of all items entered. Okay, we actually did this the other day. Go through and ask for a bunch of values, add them all up. It's a summation pattern. All right, but it's also a counted loop, because it says right up front, ask the user to enter 10 items. So we know in advance how many things are coming. We'll make a change to this in a few seconds if I don't forget. Let me make a note right here. Well, that's not helpful. I'm typing upside down. Okay, just so I don't forget this. Okay, that's just a note for me so I don't go off. Okay, so let's go do this. Write a program that asks user to enter 10 items. Okay, excellent. Counter is equal to 0. Well, the counter is less than 10. For item number in range 10. There we go. What are we going to do? Well, we're going to ask the user for something. That's an input statement. All right, here we go. Enter item amount. There we go. Good enough for right now. So here we go. Enter the item amounts. Yes, I'm not doing anything useful, but I want to find out, does it stop after 10 times? Yeah, excellent. All right. I don't want to type 10 things over and over again. 5 is enough, and we'll put it back to 10 afterwards. Okay? All right, so we're just going to enter. Now, obviously we need to do something with this. We need to store this as the amount. Oh, and I bet the amount's probably an integer or a float or something, so I can do some stuff with it. Hey, we're still going to need a total like we had before, so let's initialize a total to be 0. That's going to be my accumulator. And just after I enter the amount, I'm going to say that total is equal to total plus the amount. And finally, when we're finished, we'll print out some kind of a message, the blah, 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 blah. Okay, the total amount I've entered is total. Okay, so whatever the message is. All right, let's run it, find out. It's only going to ask 5 times, just so we can make it nice and quick. So we have a 50, we have a 10, we have a 5 and a 5. How much do we have so far? 70 so far. And I'll put a 1 here, so the final thing, so it should be 71. All right, good, so the total is 71. Again, is it convenient? I think the answer is yes. It really is convenient. If you know how many things are going to happen, this is really, really, really useful. Okay, now, got a couple of things that I want to include because we did some stuff previous class, where I included a few extra words in here, and these don't necessarily work the same way. I want to change up my program just a little tiny bit. Instead of just saying enter item amount, I would like to include the item number amount. Okay, I'll turn that into an F string. All right, because what I want to do is I want to say, please enter item 1 amount, item 2 amount, item 3 amount. The first thing, of course, that happens is it says enter item 0 amount. I mean, that's true for the computer, but maybe not what we want. Okay, so pretty simple fix to that. Yeah, just +1 when you're going to display it. Don't change the value, just +1. Oh, changing the amounts. Oh. There's a second problem we need to come up with. Change the counter variable. We better find out what happens with that. All right, so enter item amount 1. Okay, 1, 2, 3, 4, 5. How much? 15. Memorize that one because we use it all the time. Okay. All right, so here we go, 15. Okay, perfect. So it's working and it's now prompting the user for the correct values. All right, let's try doing some stuff. Let's make sure, okay, because we were starting to do stuff like this last time. If amount is exactly equal to a -1, we did some stuff the other day where basically I said break. Okay, so the question becomes is, are we allowed to use a break inside a for loop? Okay, seems reasonable. And all those things seem reasonable, you know, there are languages where you have types of problems. Like, for example, I mean, it does work here. I'll demonstrate in a second. But if you happen to be one of the IT students who go on and take a course called Web Technologies 2, you very quickly find out that there's a really nice construct called a for each loop, and you can't break. And people are always just like, how does it work? And it's because they didn't support it. All right, but in any case, here we go. So pretty simple. So enter amount, there's a 34 and a 10. So the total rate now is 44. If I put a -1, it's finished. Okay, yeah, it breaks just like a while loop, so that's useful. But if you remember, there was another one as well called continue. So what I'm going to do is, just to make the program as simple as possible, if somebody enters a really big number, let's print a message and say, that is too much. Okay, or whatever we're doing. Maybe it's too much. Maybe it's a score or something. And if, of course, if I break, it's going to stop the entire program. But remember what a continue does. A continue stops the program stops the loop from continuing where it is, but it doesn't stop the loop itself. It just goes back up and it continues to check. Okay, we kind of use that for some error corrections or some error detections previous class. All right, let's see what happens when I run it this time, because this one is a little bit surprising. All right, so here we go. The first value gets put in as a 50. Okay, not a big surprise. Total is 50. All right, so now I'm going to type 150. When I type 150, I am definitely going to see that is too much. Okay, and then it says continue. The continue would normally say, well, and it does, by the way, it's going to say skip over line 13. The rest of the loop is skipped. So in other words, total is not going to go up by 150. It's going to be ignored. Okay, and that's true. It says too much, but take a look at the item number. The item number continued to go anyway, because if you continue, it just takes the next number in the range. It's not like a while loop where you can skip over the increment. Okay, so just watch out for that one. All right, so now based on this, we better do two more things. The first one I want to do, I don't want to do actually, but I think it's better to get this one out of the way, because you might be asked to program about this. Write a program that asks the user to enter n item amounts where n is asked before the program starts. Okay, you get the idea. What I'm going to do is I'm going to ask, how many items are you about to enter? Okay, and we're going to get rid of the continue. It works, you just have to be aware what it's doing. And sometimes you want it. It's just you have to be aware that you will get the next value. If you want to skip one of the values, you have to convert it to a while. It's one of the reasons why you might use a while loop for a counted. All right, here's what I'm going to do. Enter item, whatever. Okay, before I start, I'm going to ask total items. And I'm going to ask input how many items. Okay, so this contains this. Well, That's just a variable. Okay, so it can be whatever variable you want. So you just ask the user how many, and yeah, that becomes the range. And we'll terminate this, and we'll make sure this works. I'm about to enter 3 items, 1, 1, and 1, and it totals out to be 3. Okay. All right, so yes, you can certainly ask the user in advance. Now, I need to come up with some very, very strange little concoction, and I think this really should be added to the slides. I'll make note of this. It's probably the issue. I'm going to have to be very careful about what I do. Okay, for counter is equal to, counter in range 5. That's not a trick question. How many times is the loop going to happen? 5 times. Okay, good. All right, here's what I'm going to do. I'm going to ask for a value. So this could be like one of these tracing problems. Enter the value. Okay, nothing very difficult here, just 5 values and then it stops. But I'm kind of interested in doing this. If the value is equal to 10, okay, just for something to do, I'm going to set the counter equal to 100. All right, and print done. All right, so I suppose if this is a trace question, I'd probably say, what's the output if the user enters 1 and then followed by 10 followed by 1? I guess that's the question. All right, because what's going on here is when the person types in a 10, what happens on line 4 obviously gets triggered. And the question becomes, if the counter suddenly becomes 100, does that stop? Yeah, does that stop, or is this a problem, or what ends up happening? Okay, let's find out. All right, so the first one is not an issue. Okay, yeah, things are going. What's the value of counter right now?
0.
Yeah, currently it's 1. All right, so I'll put in another 1, so now the counter value is 2. Okay, but then I'm going to type in this magic number 10, and I suppose we better find out what happens.
You have a range.
So unfortunately, I don't really know. But if I go another 2, hey, look at that, it stopped. It still stopped after 5. So changing the counter actually doesn't change the counter? Well, it does change it, but it changes it just for the current iteration. And when you go back, it goes back to whatever the next value is in the range. So let's print it out this way so it makes it very, very clear. I'm going to say up here, start of loop body counter. Okay, and right here at the very end, I'm going to say f end of loop body counter, so we can see what's going on inside, because if we don't know what's going on inside, we're going to have a problem. This makes sense. It starts at 0. We put in a number like 2, that's not a problem case. So we're going to see end of body, and what's the value going to be at the end of body? Still 0. Okay, what's it going to be at the start of the body the next time through? It'll go up by 1 because it'll be the next value in the range. All right, so let's do it again, another 2. At the end of the loop body, what's the loop body going to say? It'll say end of loop body 1, and then it will immediately say start of loop body 2. Okay, very good. Let's put in a 10, because here's where things get a little bit funny. What's it going to say end of loop body?
End of loop body 2.
100.
Yeah, it's going to be 100 because we just changed it. But when we go back up to the top, it'll pick up the next value in the range. Okay, so you are allowed to change it, but it's kind of like a temporary change. Okay, just watch out for this. My recommendation, okay, when programming, don't change the loop body value. Okay, if you're using it for range, don't change the loop variable. Just leave it. Okay, there's no reason for you to change it. If you need to change it for something, make a new variable and make a copy of it, because this could be very, very confusing. Okay, but unfortunately, it's a fact of life. So yes, it just means pick up the next value from the range. Okay, what do we got coming up next? Ooh, okay, ready for some new stuff? Okay, well, actually, it isn't new stuff. It's stuff we've actually seen before. Okay, so here we go. Oh yeah.
What's the meaning of counter? Being there.
Oh, that's just the name of a variable.
But you can't enter anything and you can't use it.
Yep. Yeah, you can use whatever variable name you want. You can use it for whatever purpose. When I had the example up a few seconds ago, here we go. There's the example. Sorry.
You can name method count as
Yeah, yeah, and you can always make it. It's just a regular everyday variable. It just has this weird business that if you change it, it'll pick up the next value in the range, the next iteration. Okay. All right, and of course it can be whatever name you want. Okay, let's go back over here. Okay, 4. Okay, remember, this is just a variable. Okay, so my slides show I. All right, so here's what we're going to do. For counter in range 5 and print counter, this is going to be like super, super simple. All right, what am I going to see? So we'll terminate this, we'll clear the output. What am I going to see?
0 to 4.
Yeah, 0 to 4. Okay, yeah, don't start with 1. All right, 0 to 4, absolutely perfect. This is what we're looking for. All right. All right, there's another option. Okay, not only can you put just a single number, you can put 2 numbers. The 2 numbers works exactly like list slicing. Okay, you have a starting value and you have an ending value. Is the ending value part of it? No, it's exactly the same thing here. So the output of this, the very first number will be 3, and the very last number will be 6. That's exactly it. Okay, so if for some reason you have to start partway through a range and go to the end, yeah, you can do this type of thing. And I'm just going to make this one just a little bit bigger, okay, because then I have to show you the third variation, which is add another value to it. Okay, and again, it works just like list slicing. The third parameter in list slicing after the second colon tells you how many things to skip each time. So what this says start at 3, go all the way to 17, but don't include 17. Okay, but add 2 each time. So
5, 7.
yeah, 3, 5, 7, 9, 11, 13, 5, 15. But don't include the 17 because we made it, because we don't need to go that far. And if you were to do something like this, okay, we better predict the output of this one. I think these show up in like quiz questions, like
15. Stops.
yeah, 3 and 13,
Stops.
and it won't go any further because the next one is way too much. Okay, all right, useful? No. They're here because you do have these options. There's always the question I like to ask is how often do I ever find myself using them? No. Unfortunately, they're still part of the course, but to be honest, they're not used that frequently. Okay, but sometimes you need them. Okay, sometimes you need them. There's one little curious problem, and we kind of have seen this before, and I suppose that this one's probably worthwhile. All right, 10. Oh, 0. Okay, here, let's clear this one. What happens here? Start at 10, go all the way to 0. Yeah, we're already past. And then print this out, and we better print the word done just so we know that our program has actually ran. Yeah, it doesn't work at all.
Yeah.
Okay. If you wanted to, you can stick a -1. Okay, so what this will do, the very first number will be 10. And then 9, 8, 7, 6, 5, 4, 3, 2, 1, and doesn't include the 0. No, because it never includes the very last item. So if you're looking for 10 down to 0, you'll have to do some weird thing, like you'll have to go to a -1. Okay, and that would include the extra. All right, this one I could see having some use if you wanted to have a bunch of numbers go backwards. But I'll be honest, whenever I'm writing any code, if I've got a simple for loop, which is starting from 0, going to the end, or maybe starting from 1 and going up to a value, I'll use a range. Otherwise, I'll probably just use a while loop. If I'm doing weird things like skipping things or going backwards, I tend to use while loops. That doesn't mean that they're incorrect. Obviously, you can use these things. Okay, so finally, let's get back to some real problems again. Okay, so other uses of for loops. All right, let me consider a small problem first. Okay, and we'll find out what we got. So we have a course called INFS 1201. I think that's probably more than enough stuff. Okay? All right. If I wanted to print out one character, we already know how this works. You say print course at a given position. Okay, and this will print out I. Okay, yeah, nothing funny about this. All right, and of course, if I ask for number 2, F. Okay, so nothing funny about this one, but here's what I'm going to do. Each of those positions are usually called an index. Sometimes I call it POS for position. Okay, sometimes I use IDX because I'm really lazy and don't want to type the word index. Okay, but you can even use the letter I. I really don't like the letter I. I is okay as loop counters. In fact, you'll probably see these things. Well, here you go. There's some examples right there. So do I use the single letters? Yeah, sometimes I do. I is usually a loop counter where it's a small integer. This is pretty well standard. You're going to see a lot of complaints from various instructors saying, no, you got to use words other than just I. For this purpose, it's probably all right. But I'm going to use index, just so we know exactly what it is. That could also be a reason why they use the letter I. We'll eventually see this as we start to deal with really big data structures. For example, when I have a big collection of students, I sometimes use S to represent a student because it's pretty easy to read from the context. All right, but here we go. I'm going to start. Oh, where's the first character? It's at 0, right? Position 0. So what I'm going to do is I'm going to set up a while loop. I don't know what I'm going to put in here yet, so I'm just going to say true. It's my placeholder. Yeah, I know, it's an infinite loop. We'll fix it in a second. All right, here's what we're going to do. I'm going to pull out a character. Again, I don't need to do this, just so I can say it. Here we go. I'm going to go to course, and I'm going to pick out the value of index. All right, so remember, what is CH? That is exactly one character. And I am going to print CH. I'm not going to do anything else yet. Okay? When I run this program, what am I going to see? It's an infinite. What am I going to see? I know it's infinite.
I.
Yeah, it's a whole pile of I's. Okay, let's terminate kind of quickly. Okay, yeah, it's just I. Okay, let's make this a little bit more interesting. Instead of just printing the same index, because index never changes, I mean, we've been doing stuff that kind of looks like this. That's a counted loop. Okay? So index is equal to 0. It doesn't have a stopping condition yet, but what I'm going to do is I'm going to get the character at position 0, then I'm going to increment I, and I'm going to pick up the character at position 1, then 2, then 3, then 4, then 5, and so on. When I run this, it starts to print things out. Of course, eventually, it caused a whole pile of trouble because index just got too big. Because once index hit, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Once index hit 8, crash. Index was out of range. Okay? All right. So instead of going for an infinite amount of time, maybe I need some kind of a condition to stop everything. All right, and the condition would be, well, while index is less than 8. All right. See, now what I'm doing is I'm pulling out each of the characters and I'm printing it. Of course, it doesn't work. Here, we'll use the unofficial name of this course that already uses. Oh, sorry, this one. All right, so here we go. If I run this program right now, what do I see? Error? No, it's perfectly fine. But the issue is that I only see the first 8 characters because that's what I've said. So only show the 8. Now, the thing is I would have to go and I'd have to count this up by hand to figure out how many characters I've got and then make the appropriate adjustment. I don't know if that's enough or not. Nobody wants to count stuff by hand. However, we do have a function called len. And len will tell us the number of characters that something has. You see, now this works exactly what I want, and it doesn't matter what I put in here. So intro to Python, bang. Everything now continues to work exactly as expected. So that's a very convenient thing, and you will see this while the index is less than the length of something. Oh, and of course you notice that index starts at 0, not at 1. That's the reason why I suggest that you get used to starting counted loops starting from 0. All right, so that's very simple. Okay, it's very, very useful. Sometimes you're writing programs like this because you want to find out how many spaces are here. How many capital letters do I have? How many lowercase letters do I have? How many digits do I have? These are all types of problems that you can solve using this problem or using this technique. That is a counted loop. Well, guess what? This type of thing where you're iterating through strings, I better wait for a few seconds.
So, can you please explain how this works?
This is a very good.
Okay, so we've got ourselves a counted loop that starts from 0. It increments each time. That's the counted loop pattern.
Yeah.
And what I'm doing is I'm saying, well, the index is less than the number of characters in the string. Okay, so I'm going to pick up position 0, position 1, position 2, position 3. Inside the loop, when you ask for a square bracket and a single value, that was pulling out exactly one character. And then, of course, printing it. Okay? Okay, already done? All right, so here we go. This type of thing does happen quite frequently. And guess what? Programmers, I've said it before, are notoriously lazy, and they always want to come up with things to make their jobs easier. Unfortunately, it's one extra thing that we have to learn, but it's probably a very, very handy, convenient item. So watch this. I'm going to turn this into a for loop. They've actually done a really nice job with this one. Not all languages have this feature. Quite a few of them do, and Python does. So here we go, for. Now, I know what you're going to think. You're going to say for index in range. Here we go, in range length of course. Yeah, that could work, but there's actually an easier way. Instead, you simply say for index in course. Well, actually, I'm just going to use the value x, and I will replace this in a second once we see what's in here. Just print x. Okay, let's see what x is. Okay, here we go. Clear the output and run it. What's x? It's the individual characters, and I didn't have to use the square brackets to get it. That is very, very convenient. So if you have to go through all the characters in a string, this is an excellent way how to do it. Okay, we're going to be using this approach all the time, because what we're going to hit after we do a quick review of functions is we're going to start looking at data structures called lists, and pretty much you're going to see me use for in all the time. Okay. Oh, so in other words, the in operator, and this is a bit of a problem with a string, the in operator could mean that you want to see if something is there, and if you use it with a for, it's used to go through all the items. Okay. Yeah.
So how did X
So what happens is this picks up all the values of the string one character at a time. So what will happen is it will go through, it will pick up the first character I, that will be the value of x. You do your loop, you do whatever's inside, the next iteration through, it will pick up the n. The next time through, it'll pick up the f, and then it'll pick up the s. Okay. It's a very convenient thing because you don't have to use the square brackets to extract the characters. No, you remember, these are for loops. You don't need to do this. All of this stuff is looked after automatically in the background. So it's doing all of that stuff that you might forget. Okay, so it really is just a convenience. Do you need for loops in order to get through life in terms of programming? And the answer is no, you don't. Do you want to use them? Actually, you do. Okay, really, you do. I know you look at this now and go, it's just another thing. No, these are so convenient. You'll probably hardly ever see me write while loops. And most of the time when I write a while loop, I start by writing an infinite loop. Well, I figure out how I'm going to stop. But for loops, I don't need to deal with that because you can say, okay, give me every one of these items that are here. Okay, now I think I have an actual problem. Yes, here we go. Come on, here we go. All right, here we go. I'll do something a little bit different than what's in the slides, but it's almost exactly the same thing. So let's ask the user to enter a string, okay, and count the number of punctuation characters in that string. Okay, so example, here we go. We can clear this one up. Okay, how many punctuation characters are in the string this sentence with punctuation is finished? Okay, you know what punctuation is?
Yes.
Yeah, okay, so how many punctuation characters are in this string? Yeah, 3. The comma is there. It shows up twice. All right. And a full stop is at the end. So 3 of them. Okay, pretty straight. But of course, we've got to solve this so it works no matter what the person types. Okay, and they could end up typing just about anything. All right, so first thing up is I'm going to have a sentence, and I'm going to ask the user to please enter. Oh, sorry, it's not be an integer. Input, enter a sentence. Okay, only one. And then what I'm going to do is I want to iterate through each of these. Well, let's start with this. For ch in sentence, because what that is, that's a bunch of characters. Bang, here we go. And if I were to steal this one right here, I can be lazy. So here we go, copy and paste. All right, so it is actually here. It's a little bit of a problem because I've got the font zoomed in. But anyway, so the whole sentence is there, and it comes up and it prints absolutely everything. This sentence, comma, with punctuation, comma, is finished. All the characters are there. Very, very convenient. I don't need to pick out the location. I don't need to use the square bracket operator. I don't need to increment to go to the next character. It just happens. Yeah.
What's a CH?
Character. Yeah, because I actually use it right here. What's a character is an individual symbol inside a string.
Yeah,
Okay, and it turns out it doesn't matter even if it's like an emoji. It still is a character. At least I hope. We can try in a few minutes and find out. Yeah.
I can always use for instead of while.
Ooh, can you always use for instead of while? If you have a counted loop, you can always use a for. If you're trying to implement a sentinel-based loop, for loops will always terminate. So if you have something that is going to go for an unknown number of times, you have no choice but to use a while. Okay? So they're almost interchangeable. For counted loops, they will be. It's whatever is most convenient.
Can I use them both?
What do you mean both? Of course you can.
Inside.
Yeah, of course. You can put whatever you want inside. So you can have a for loop on the outside and you put a while loop inside, if that's a problem we're trying to solve.
It's useful.
If you need a nested loop, yes. And yeah, these types of things I do quite often. All right, this right now just prints everything. I'm not interested in printing these. I want to count which ones are actual punctuation marks. So we need to figure out, how do we know if we have a punctuation mark? So here's what I'm going to do. I'm going to put an if statement. Okay. If the character, and we covered this one the other day, is in the following things. Right? So what you can do is there. What that's asking, it's another use of an in. That's asking, is CH in any of the following items? Is it an A, is it a B, is it a C? I'm not interested in if it's an A or B or C. I want to know if it's any of these things, or this one, or this one, or this one, or this one. I think that's all. Even some of these I wouldn't even call punctuation marks. So let's see, not that, not that, not that, not that. Okay, I think, there we go. Okay, I think that's all the punctuation marks. If not, this is good enough for this time. Here's what I'm going to do. I just want to print it for right now. So what's this going to do? Well, this is going to print all the punctuation marks, but only the punctuation marks. What about the other CHs? Well, we won't see them. Okay, enter a sentence, paste. Good, it's still here. There you go, comma, comma, full stop. Yeah, okay, so I managed to get rid of things by, again, just using one of these loops one of these for loops, so I don't have to remember to pull out the position and so on. All right, so the only thing that's left is I just need to count things. Well, we know how to count things. Counting things, you have a counter. I'll call it a punctuation count, punc count. Okay, I'm going to start it off as equal to 0. Instead of printing it, I'm going to take the punc count and I'm going to set it equal to punc count plus 1. All right, and then down here I'll say whatever this is, punc count. There we go. All right, so paste it in again, and it comes back 3. Okay. You know, the most important thing here is maybe not necessarily this, but notice the process that I used. I printed what I wanted to see first. Okay, I printed everything. And by the way, you're going to see me do this. When we start dealing with lists and start dealing with dictionaries, one of the first things I'm going to do is I'm going to say, okay, just print it all. And then I'm going to say, okay, I'm not interested in all, I'm just interested in some things. Once I can see what I'm trying to track down, well, then I start to worry about the logic for actually counting. Okay, it's a reasonable process to work through. Again, you don't just write the entire program and say hope for the best and then figure out what went wrong afterwards. It's a very, very difficult way because sometimes you don't actually have any idea what it is you're even looking at. Printing what you've got, a very, very useful way. Okay, so that's this example. What else do I have as an example? I'm almost there. Oh, and I think we're done. Okay, well, I said sometimes I will finish a little bit earlier. So here, let's just do a quick one of these. So yeah, we've already been through that. Okay, when to use a for loop. Basically, if you know how many times you're going to use a for loop in advance, a loop in advance, for loops, and can you use them whenever you want? And the answer is yes. Okay, whenever you want to use them, use them. You can't use them unless you know how many times something's going to happen in advance. That's the only restriction. Okay. Otherwise, you can use them whichever is easiest. Here we go. Here's the example. We've already talked about the start, stop, and step. As I said, in reality, this having things start, stop, and step, it's not something that really is used that often, but you certainly can use it. We talked about looping over a string. That was the example for counting a number of punctuation marks. And of course, it comes back to when do you use these things? Okay, if you're counting from one to a number or from something to another, a for loop is probably easiest. If you're going to keep asking until some condition is true, it's definitely a while. And in fact, you don't have any choice. That's also the same if you're checking for a condition. If you're going over a bunch of characters in a string, a for loop is really easy. Okay, it doesn't mean you can't use a while, it's just really easy. The final slide that was here was just about the break and continue operators, but we've already covered it. Just the only thing to remember is that a continue will go to the next value. And I also had to make a note now to say, don't forget to talk about corrupting the loop counter, because obviously that can have some very unexpected circumstances. So even if you change the value of I, in this case, partway through, it'll just reset and keep on going whatever value comes next. Okay, all right, and then it says thank you. Okay, perfect. So we're done.